I'm back. Sorry you came so fast into the chat, I didn't even see you. Look at this. It's insane. I'm creating eyeballs for my AI. What do you think? I'm giving it a brain on being able to identify what objects and obstructs there are. Okay, so how well are they performing? So what I did is I gave my AI that I've designed here this room, right? I gave him a picture of a room. And I want this AI to identify lines in this image. Well, you see, in a video game, what is a video game? It's a 3D representation. It's a 3D representation of that's spoken in 2D. I'm gonna explain that. What is this image really? Well, if we zoom in, it's just a bunch of pixels, right? Just a bunch of pixels, right? That's all it is. It's a flat image, but to our eyes, in the way that we see it, well, we say, oh, dark means that there's something is further away than light. Light is closer, right? But to a robot, this is exactly what it is. It is a two-dimensional freaking bunch of squares put together, right? Why are our sorry, add pop-ups in my operating system? Don't do that, Windows. So how do we take an AI and make it see three-dimensionally, right? Well, an AI has to be tricked into thinking that this is a three-dimensional object. So we have to use human perception to do that, right? So in a human perceptional way of seeing things is how we have to translate that to the AI. So we're going to tell the AI to look for lines. And then we're going to take those lines and create a three-dimensional space for the AI, right? Let me explain. So we created our AI to find all of the lines. Here, it worked. It works really well. He's drawn those lines over everything. Now, the next step is for him to create three-dimensional spaces out of these two-dimensional areas, right? Is genius. It's truly genius. Then, once he has found those three-dimensional spaces, right, he can start to walk through these three-dimensional spaces. Why is this important? Well, it means that when we're playing Hitman, all right, and that engine that we're creating right now is running, he can look down a hallway, create a three-dimensional area of what he's interpreting on the 2D space of the gameplay, and he can see the different routes he's able to go down, the lefts and rights he's able to turn. And it'll work for any game because I'm so sick and tired of doing micromanagement, right? And the fact that it's already working, uh, it's like halfway done, and I started it 25 minutes ago off of this crazy idea of perspective. The theory will work. No, Jarvis is my AI that I built, and he's my helper. He runs in Amazon Web Services. I mean, if I spent the next 3.5 years, okay, making an AI, well, first of all, no. Dude, I could literally just fuck everything up. Dude, I could take Purple Key's run and have the AI do it perfectly over and over and over again and get better at doing it over and over and over again and over and over and over and over again, and he could just be on like inhumanly fast, just inhumanly quick, right? Just like, okay, here's the glitch. This is the commands to do the glitch. Okay, program the glitch in there. Okay, walk up to this door. Okay. All right, do the glitch. Okay. Shoot the target in like half of one frame. Okay. Like shoot the target in one frame, dude. We're talking about 60 frames per second, right? In one micro frame, right? Shoot the target in the head, right? Pow, just right, and then like just like there nothing could beat that, and I could do that, and that's why I'm working on the hive mind. Okay, the Mecha Hive Mind program, and I thought about how I'm going to evolve this program. I'm going to make it the most ultimate macro game controller of all time. And right now I'm working on giving it eyes. And I'll add on to that later. The winner is AI, dude. The winner would literally be Jarvis, dude. Jarvis would I'd take all the money and throw it right back into Jarvis. But yeah, but there's a game called Tracks, or was it Track World? Yeah, like Track World. And they use that. Speedrunners use AI to drop world records. It's not uncommon. They use automation to drop world records. It's actually a part of the speedrunning community, which is kind of cool. I don't even care. Like, it's not you though, dude. It's an AI. But tell that to the entire track world community. They don't. Yeah, Trackmania. Thank you. Thank you. Thank you. All right, now we're gonna see if it's going to take that 2D objects, turn them into three-dimensional spaces. Render a 3D world. By the way, I'm using the same technology. So we're using CV, right? So you know when you're in a car and the back of the car is got the lines or whatever, right? That identify um how far or close an object is to the vehicle on your backup camera, and then it starts to beep 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 beep, right? When you're about to hit something. The same exact engine, right? The same exact CV, open CV is what I'm using to do this. So I'm using literal real life radar technology, right, to do this in video games. I'm basically making a backup camera for video games right now. But I'm re-engineering it. Yeah, we're using technology from cars. Car radars. Which is pretty sweet. All right. I think this is going to Pathfinder. Here we go. Pathfinder version 2. Holy shit. What is that shit, dude? That is strange. That is fucking strange. Holy smokes. It tried, dude. It tried. Okay. All right. I'm going to take the eyes.png. Okay. And we have to add a step here. We have to add a step here. So I'm going to take this, right? So a step before we pathfind, we take these lines seen in photo 1. We're going to open up Paint. And we're going to, I use AI when making AI. Why? Because I would be a dumbass not to. Right? It's like the wrench, okay? If I'm using an electric wrench and you're using not an electric wrench, I'm going to move faster than you. But if I get good at using an electric wrench, okay, suck it. All right. All right. So now what we need to do is we need to create three-dimensional space and time. So to do that, it needs to start to identify actual 3 dimensions. And now it should render these as 3-dimensional objects. Instead of turning the image, as it turned the image into a 3-dimensional block, it did that. Now I'm going to have to do cubic science here. In my representation of what the AI needs to try to identify. Okay. I think that's going to be enough for him to understand what I'm going for. All right. Perfect. It's exactly what I wanted him to see. A step is we pathfind, we take these lines seen before in photo 1. In photo 2, a step of three-dimensional, or 3Ding, we'll say 3Ding the space. I drew up an example. That's genius. I mean, it's absolutely genius. And it pseudo 3D space by extracting vertical and horizon edges, green lines in the photo 1, connecting and extending the lines, and forming a geometric structure, red lines in photo 2, applying a perspective correction in depth and estimation to make sense of navigation in 3D. That is correct. You understand exactly my shitty art skills for the win. Microsoft Paint for the win, dude. Helps me describe exactly what I'm trying to explain. But once it sees this 3-dimensional space, right? It actually has to render this in 3 dimensions, because if it renders it in 2 dimensions, it'll just be a bunch of lines. So once it renders that, it'll actually create a way to move forward. But here's the kicker. Things are going to change all the time. So I need to create an instance buffer, okay, to where one sheet of 3 dimensions is ready to go. Is if we're moving 60 frames a second, I need to create what I designed in my smart big brain is going to be called walls. And walls are going to appear in a three-dimensional space that's X, Y, and Z, depending on what the base image is. And when it detects a wall, it's going to say, I can't go there. Now, that wall might be like, this big, and it may not be accurate. It may not be as accurate in trying to identify this area, right? But that wall, right, may just be enough to block just the possibility of walking here to the left, right? It's just an inference, right? Imagine this was filled in, right? This big square that I drew here is filled in. And these walls are going to appear all over the place. Now, are we going to have inconsistencies? Yeah. Is the AI going to maybe try to go left, but then the wall's going to appear and then go right and then go left again? And yeah, that could happen. But that's how we make it fast, right? That's how we make it fast. That's how we make it fast. And I'll call it the walls because that's what it is. All right, I'm scared to run this. Here we go. It's a lot shorter. Okay, we have problems. But hold a freaking phone, dog. It work? Hold on. No. Render it in 3D. Just the green. Inference. I don't feel like spelling today. Okay, so this is a strange perspective that this eye is seeing here. I mean, it is very freaking weird, but I have news. It did route a path. The red lines represent the path that it could potentially take before it stops. I don't know what the fuck the blue is. Okay. But look, it's basically saying, right, that we are able to walk down this hallway. We're able to walk down this hallway. And once we get to the end of the hallway where there's a left turn, it doesn't know where to go beyond that point, which is good because then at that point it's going to receive new images, right, of the world around it. So we are making progress, but its perspective is all super gooey. So this is the base image, right? This is what it sees, right? This hallway, right? And we're just taking snapshots of memories and ideas. Once that's done, we'll apply it to an actual engine that will take it on live, right? We're using an image right now. So walk down this hallway and take a left, boy, right? Well, it can't take a left, right? So it's going to walk down the hallway. It's going to walk down the hallway. And I asked it to make red for its path. And it is walking down the hallway. That's pretty crazy, dude, because that's exactly how you would do it. That's exactly how your brain would do it. You would walk down to an area of the hallway, reevaluate your surroundings, and then figure out your next move, right? So this is great. This is great. It's just the world is very distorted. So obviously his path is going to be a lot different, and we got to fix that. So let's go ahead and see if we can't try to map out the three-dimensional world here. Oh, I had to reinstall Windows. And we need the PIP for MATA. All right. I know I have NumPy. All right. Anyway, CMD, run as administrator. This is how you install binary interpreters. You use special powers. And then hacker life type shit. Okay, that's done. All right, now I have meta. Now I run it. And that makes no sense. I figured as such. The fuck? Inference. Inference. Extract just the 3 green lines from the first part of the equation that CV does. Then create a mathematical algorithm that takes that and then squares it. As seen in my second photo that I sent you for my example with the red boxes. Then render the 3D space three-dimensionally. The edge detections on a mathematical infer depth by square detect structure as seen in your second image. Reconstruct the environment in 3D using 3D visualization engines. Render in true 3D representation Walls' box-like structure. That's correct. So what I tried to do here is create an it tried to create like this chart, right? Which that does nothing for us. But what happened though is we did have an actual chart, meaning that it did place those lines three-dimensionally inside of a chart. So that means that this is possible. You know, it doesn't need to be 100% perfect. It just needs to give us a certain amount, right? We just need to see it to believe it. You know what I mean? You know what I'm saying? We just need to see it to believe it. Now, this could work alone. I don't even think, I mean, this theoretically right here could work. I know this looks like weird to humans, but this is, if the robot is identifying that we can walk straight, That's good. That's good for me. I mean, that's great. But the robot needs to identify a lot deeper than that. Like a lot deeper than that. All right. So we wanted we're looking for something kind of like this, right? Where it's going to inference in cubic everything, right? So that's really where we're at. And so this is where it gets kind of heavy. Um, I doubt this will work. Okay, open 3D. Okay. We need the PIP for open 3D. All right, I figured it was open 3D, but you never know. It might have been open 3D something else. We got to install open 3D. All right, installing that. That's a big one. Okay. Does it have any dependencies that I don't have? Um, Holy shit. That's huge. This is a huge package. Well, when you're doing 3D rendering, it's definitely huge. It's still not done. It's still not done. It is still going. So it's doing stack data requests, plotly, matplotlib, but a special one. What is that? Inline. So matplotlib inline. Jupyter Core, Jinja 2, Jedi, import lib metadata, com, John's schema, specifications. It's man, that's a lot. It's still going. I wish it was telling me and updating me on which one it was at. But it's still going. So I'm gonna try to run it. No, it's still going. How long is that gonna take? Let me see if it's actually doing anything here. Okay. So zip has gotten installed. Because it needed zip. Let's see your Jedi. There it goes. Okay, so dash core components, decoder, blah, 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 blah. Okay. Okay, it did it. It did it. All right. It's doing something. It's doing it. It did it! Oh my gosh. We have a three-dimensional space. And it's just a blink. It's a blink. We have just an absolute flash. We have a flash of where he can go and where he can't go. It doesn't make a lot of sense. But this is great because this means, right, that we know that he can't walk to the left. He can't really walk to the right now. He can only walk straight. Yes. All right. Let's test it out. Okay. Let's this is great. This is great. All right. So what I'm going to do is I'm going to go to my pictures. I'm going to go to my screenshot or sorry. I'm going to go to not my pictures. I'm going to go to my Hive Mind. I'm going to go to my assets and I'm going to go ahead and delete eyes 3D and eyes. I'm still going to keep this because this is absolutely beautiful. It's my art piece. A trophy. Okay. I'm going to rename this though because it will interfere with the scripts. So I'm going to say IC1 and now we're going to go to the internet. We're going to find another hallway image. This one. This one is good. This one is good. There's like a rug. There's all sorts of cool stuff, right? So we're gonna take a little photo of that. Cool. All right. And we're gonna paste it here. It doesn't let me. It's so stupid. Control C, go back, and we're gonna paste it here. We're going to name it eyes. There we go. We named it eyes. Now, if we run our program, it's going to use that as a reference now. Okay, we got an error here. It says C++ error. Assertion failed. Empty function. So wait, I'm going to find out. Hold on. Oh, okay. All right. Okay, hold on. Added the process to edge eyes.png from before, then this step. That's what's happening. So he basically created this the step afterwards, and now we're going to integrate the first edge. The edge there. So we're going to give him some time to add our. And so let's just like pull up some predictions here for this, right? It should be around the same kind of thing. We should see more open on this side than on this side. It's a lower resolution though. It's a very low res image. I can close these because I already installed those packages. So now what we're gonna do is see if he's done. No, he's still going because this is a big code. It's big. Now we need to start identifying different three-dimensional spaces like what the floor's shape is. And that's going to help me out. Because then we lightweight this app to just identify this floor's shape. And if we can identify what the floor's shape is, we've created radar. We don't have to worry about walls because where the floor ends is a wall. Big brain, big brain. That's going to light and weight that 3D render because that 3D render takes time. So then we're going to have floor. I bet you this is how they make those stupid little robots that drive around the ground. No, those are just probably sensors. They're just sensor driven. But we have no way of sensors. Unless I create a virtual sensor that shoots out different directions to get flash three-dimensional objects in 3D space. We could do that. We could try that. So to shoot a sensor to the left of the image, that would then like print just like this kind of splash of what is on the left there and three-dimensionalize it. And be like, ah, that's a wall. We create virtual sensors this way. That's crazy that we could do that. There's so many different approaches. We could do the ground. All right, this is done. All right, here we go. It's looking for eyes.png. Yes, I checked the code real quick. Glanced it. Bah. All right, we got problems. We have problems. So basically, things went south, which is okay. I love the shine, dude. There's like shine to it. It's so cool. It's so sick. Okay, so it looks like we might have to go with the floor. Now I'm going to do a compare contrast here. So our three-dimensional lines here identified. Okay, so basically what's happening here, okay, is that this fucking sucker, right, is just so low res that it can't identify jack diddly shit. But theoretically, the AI would walk through this line here, which if we compared this to the original image, the AI would walk down the road down this path here of least resistance. I mean, it would still work. That would still work. So this already works. It's just like it just works. It's not very accurate. I'm seeing all of the failures. I'm seeing every failure here. That is so cool. Look at that, guys. So we are getting places. I like to visually, right, develop, right? Because if I'm visually able to develop, I can understand how to create eyes, right? Okay. It's cool. It's really cool. John, how would you approach it? Would you I need a higher res image. We're gonna do that now. We have a cat in this image here. All right, here we go. I'm gonna take a photo. No, because there's stupid Pinterest logos and shit all over the place. This isn't bad. This one's nice. All right, I'm gonna remove all of that. And I'm gonna try this one now. We're gonna edit this in, we're gonna rename this to eyes. All right, now we're gonna run it. Weird. Oh, I didn't save that as a PNG. That's not a PNG, is it? It's a JPEG. Ah, that's why. All right, hold on. We're gonna edit this with photos. We're going to go here and save options, save as copy, and we're gonna change this to a PNG. We're going to go to assets, save that like that. Okay, there. Now it should stop. This is our new image. Now I'm going to go to here and see what this is. This is the JPEG. Okay. So obviously that's gone. And this is the PNG. Okay, there. Now you should find it. It worked so well. Wow. And now it is created a miniature space in which that he can walk down. Yeah, that's so good, dude. That is so good. That did that perfectly. Ah, awesome. All right, it's time to refine this thing. And let's create walls now. All right, we're gonna open up Paint for the AI. So you can understand. I don't want to run you as administrator. Administrator. All right, do this. So let's do this. Okay. Control T and bring this back out here. Ah, so I'm gonna send him a before. All right, so This is the before. Okay. We need it to inference POV scene year in photo 2. So we need to start doing photo 2. So we're going to create an algorithm. We're going to create an algorithm that takes a line and creates a 3-dimensional space. And this is the walling that I'm trying to achieve here. And it won't look perfect, right? We don't want it to really look that perfect. But this is the inference that we need. The 3 dimensions of the red should be solid green walls in the render. Along with the floor and ceiling. So now we just need to adjust the inference logic to infer a personal POV of some sort of mathematical criteria of the thing closest and the thing furthest and attaching the inference algorithm. Once it creates the inference algorithm, it should create a 3-dimensional object that is more of a hallway. And it doesn't have to be perfect. It's just a guide. So this will look more 3-dimensional because you see we have this, but it is still 2D, as you can see. It's still 2D. And it could work. We would be walking to the right of every fucking hallway if the hallway was rendered like that. But we want to render differently. I'm going to check. I'm going to see if his algorithm is good. And if its algorithm sucks, I'm gonna just kind of make one. And it should work. I'm gonna remove IC1. We're gonna copy that. And we're gonna see if what his algorithm needs here. Let's see what did he fuck up? Image.png versus eyes. Okay. So we just need to do eyes. Oh, so he made a little mistake. Who cares? Okay, so we got. Well, that's strange. You gotta think outside the box here. Okay. Because this is a perspective of a computer. This is not the perspective of a human. I'm gonna see how these are relating. I mean, it shows us a walking path. Okay, we do have shrink here. This is shrinking. So that means that he is seeing that the end of this hallway here is shrinking. The floor or the ceiling or whatever this may be is shrinking. Now the green. Send the AI over this. See what he has to say. Because I don't know what to do. I feel like that's not terrible. It's not terrible. I mean, it can see that the hallway is physically shrinking. The green, I'm ignoring it. It's irrelevant. So it is kind of like a floor radar at that point. The inference system is working. It's crude, but it's doing it. Strange. But why is it inverted on the ceiling? That would create an infinite. No, it's symmetrical. Path of the ground. Strange. I mean, it could work. I mean, I could bend it to work. It's just, I want it to be better. I want it to be, it defines, if it just found the floor and added a wall to the edge to the top, this would be better inferencing mathematics than finding the wall's exact shape. A ceiling is irrelevant in video games. A ceiling is irrelevant. Okay, we might do that. I gotta delete IC, and I have to also change this to eyes because he fucked it all up. It's okay. Forgive you. Okay. This is symmetrical. Okay. I got a better idea. 8. Okay. I got an idea. We're going to inference the ground. Yeah. This is more genius. All right, and then we're gonna just bop. I'm just gonna manually paint it in. There. This approach is better. It's better. Let's try this approach. We're going to inference the ground only. Then three-dimensionally add our depth. So obviously, at the end of the hallway, things are smaller, right? Things that are closer to us are larger. Our POV. And we just add offsets. We add offsets then. The very end here would be always, so the dimensions of the hallway will always be static, but that's the radar's dimensions. As long as it doesn't know to actually, as long as it knows not to walk to the left or walk to the right, it will be fine. And it will be able to identify and walk through different areas. This is the best approach. Although this works, but there is an off chance that my AI could decide to walk into the wall because this line here, right? This line causes, instead of going in between these two lines, it decides to walk into the left, into the wall right here, or it decides to walk through these walls here. It's dangerous. We create a floor. We create a floor, so it's going to render the floor. Then it'll render the floor in a three-dimensional space. And that floor will evolve. So in reality, it's looking at this. Sorry. It's looking at this whole thing, but in reality, it's moving to where my red circle is stopping. That's ideal. The CV needs the floor plan. Then I'm going to do MSS, and then I'm going to have it record a floor plan render of the lines that it sees. I'm going to just play a simple game like Hitman and just see if it can actually identify the floor. Which would be great. This is fucked up. Eyes. ICPNG convert of floor plan 3D render floor plan. Yes, this is correct. All right. This approach is too in depth. There's too much to go off of. It shan't identify things that don't exist. Okay. PNG, man. Inference. Okay, orders of operations, dude. Yes. Floor plan. It's stuck. Thank you. Yeah, it's yep. Mm-hmm. Yep. Depth scaling. Yep. Walls will be inferred. No. Only walk on the floor. Okay. Anyway, now just combine those. We're not going to infer those stupid ass walls. Because we want this to be fast. I'm going to create a 3D space. And it has X, Y, and Z dimensions. Then that's going to automatically update when it's fed inference material. It's just going to get radar material. Once it gets the radar material, it could be working in MSS. Then it should be able to floor plan every single step I take in Hitman 3 or any 3D game, theoretically. We could give that learning data. We could make this a piece of a neural network, theoretically. It'd be like the most advanced eyesight for a 2D space to be converted into a 3D world. Because humans are tricked when they watch things. You're watching a painting. It's kind of sick. Movies are just paintings that move. There's nothing three-dimensional about them. Technically. Alright, here we go. Wow, it works. Wow. That was fast. We got it. Beautifully done. We have the floor. Okay. I'm very happy with this. Okay. We have the floor. Needs to render an inference. Inference that looks like this photo too. I could even circularize it. To make it more radar-like. It's a green sheet. Generate a large green sheet covering the walkable area. Renders in open 3D with perspectival depth. Alright, whole code with both steps. It is pretty sweet though. That's a lot of polys. A lot. Polys. My graphics card is crazy. To be able to render that. That is wicked. That's a lot. That is a lot. Polys. They're basically edges. All right, we're gonna get rid of the eyes.c file, and we're going to run the new one now. See what it do. Nothing. Just an empty space. Go over the OpenCV. Go over OpenCV eyes.c.png. With OpenCV to identify the floor shape in green. Then render it. Give the render a dimension that it renders within, so the depth will always be the same. Yeah, that's exactly what I want. With AI, you gotta do things in stages and steps. Can't do 50 steps in one step because then they just freak out. Do 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 do. Floor detection. This script's about to get a lot bigger. Identified a large contour. I really like this photo. That is awesome. It is basically creating three-dimensional space here. You can start to see the wood. And yeah. Lines that only go out. Now to lightweight this application, we'd have to do this all through OpenCV and only look for I forget if this is X and Y or the Z and Y, whatever, lines that are going out, not up and down. I don't know, that could actually work up and down, and this might be enough for it to work. I want to create the most advanced version though. Then I want to compress it. Then I want to make it optimized. So if we can make the most advanced version of this, then optimize it. It's the ultimate way to do it. Instead of the ghetto way of doing it. Delete this. We have a problem. I see inference triangle with an offset square. I'm genius. Yeah, that's the only way to do that. Smart. Okay. All right. Fuck, where'd it go? And then, sorry, in my brain space right now. Angles. Inference and triangle. It's very simple. And then we offset the top. Yeah.
Thank you for the follow. Smithin is always glad to see a new face.
Emma, thank you. OpenCV step 2 inference for green triangles. Then we add an offset as seen in the photo 2 I sent you to remove the top of the triangle. So the second OpenCV image should look like a green triangle with the head chopped off of it. Then we have radar. Emma, thank you. Then that's 3D rendered. Emma, we're making eyeballs for computers to take 2D images and turn them into 3D spaces. We're almost there. We're working on the floor plan right now. Truncation? Truncation? The action of cutting short something. Okay. Fascinating. Um, okay, that works. That's good. It is not good. Yeah. Yeah, I just saw that last second. Why do you keep doing that? Yes. Yes, yes, you should be doing this every time. You moron. I don't want carpal tunnel. Then I need to change the mesh. Hmm. Yeah, yeah. Okay. I see. And then I gotta clean this up because this is that's once I get the logic, I'm done. Yeah. Yep. Yeah. Hmm. That's gonna be tiny. It's gonna just drop off just a little bit, but it's okay. I can change that value. Make it so you can see. Yeah. There you go. That's Still like my other idea better. There we go. Sit, dude. White. See, truck dead. We're looking for white. Finish triangle. It's a very complicated mathematical thingy, Bob. But once he's figured it out, yeah, it just needs to inference a triangle here. Geometry. All sorts of geometry. We're looking at this image, by the way. And right now, we're just trying to get an accurate radar of the ground. Right? Once that's done, which we already have this, which is great, but we need it to understand what it's looking at. And we're going to use geometry to do that. And this fucked up everything. It just literally went blind. Stage 2. Which sucks. Alright. Hopefully this logic is better. I don't know. Fuck. Shit. We'll see. Stop. Kill. Where? Yeah. Oh, yes. Okay. Fuck yeah, dude. Right. I'm happy. All right. So on truncated, right? All right. Inference the triangle. Make it white. It's so cool. I need to play with this 3D thingy more often. This thing is sick. I also need to give dimensions for these areas. So I need to change the dimensions of this to be of space, and then it take this shape and try that lays flat this way is the goal. Then I will understand where it's at mathematically in an X, Y, and Z world format, and then it will know exactly where it's driving on X, Y, and Z geometry. Remember how I explained that computers see images like what they are. So this is a bunch of pixels. That's all it is. There's no three-dimensional anything to this. It's just a bunch of squares, right? So what we're doing is we're taking this a bunch of squares and turning it into a three-dimensional object for a computer to see. Because when we play video games, right, is we see things and they trick our brains into thinking that we're in a different space than we truly are. But we're not. We're really just looking at a bunch of squares. And we think we're in a three-dimensional world when we're not. So a computer needs to think the same way. It needs to think that it's in a three-dimensional world when it's not. Thank God for sensors, right? They make our life super easy because we can bring a three-dimensional world and a data set to a sensor a lot easier than said throwing a fucking image at it. But we don't have that ability because we can only see images. Then I want to create virtual sensors to back up another dimension of an image. And it kind of mimics sonar. It'll like flash to the left and gather three-dimensional data, and then flash to the right and gather three-dimensional data based off mathematical inferences. And once that's done, it can use its own AI to navigate through those areas. And it'll be universal for every single image. But my three-dimensional asset or environment is not tuned right. It's just a bunch of flat shelves of things, and we'll just fix that last, right? You gotta get this damn triangle inference from OpenCV to work. Once you create a triangle, good to go. Then the floor is done. It fucking did it. Yay! Super poly. My graphics card is crazy, dude. This is really nuts that my graphics card can even handle that at this high FPS. It did it. We did it. It made the fucking triangle. It inferenced the damn triangle. I'm so happy right now. Okay. That looks good to me. That looks good to me. Oh my goodness. Hey, you can walk in that triangle. And is that false? Is that false? In this instant of time, can we walk in that triangle? Can we walk in that triangle? Open. Open it with paint. Okay. Can we walk in that triangle? Can we walk in that triangle? Let's try that again. I should really get Krita, because I had it and now I don't have it because of stupidness. When we walk in that triangle, there's only one way to really do this. Yeah, yeah, we can. We can walk in that triangle. We are allowed to walk in that triangle. If we walked into that triangle, we would not hit a wall. So good, dude. You're like, dude, what are you fucking talking about? You don't get it. Okay, alright. We have a triangle. That's a very big deal. The triangle has entered the world. I'm gonna go celebrate because this is a big deal. This is one piece in a pie. My Hive Mind application is getting stronger. It's getting bigger. And I have plans to make this thing the most ultimate AI. It's going to be so sick. It's going to have digital identification for shapes. It's going to have digital identification for 3D spaces. It's going to be able to play every single video game on the freaking planet when I'm done with this thing. This is sick. This is one of my biggest, I think, projects I've worked on. Don't ask me why I'm not using PyCharm. I don't know. I was like, kind of like, I like Visual Studio. We have a triangle. Peace out. I'm gonna go order pizza. and celebrate because we got a triangle.